Hello, this is Lab 5 of Physics 2211 at Georgia Tech. We'll be talking about the motion of Slinkies today. Also, I want to go ahead and say I apologize if there's any bad audio. I've had issues with my microphone in the past. So, like I said, today we're going to explore the motion of a Slinky. A couple really important physics fundamentals to understand in order to really fully grasp this will be Newton's first law and spring force, which we will cover very shortly. And on the next slide, I will show you the experiment. And I should note that this video was taken from a YouTube channel called Veritasium, and I will link like 4 or 5 of his videos that are pertinent to this subject in the description. It's also important to note, and really the main focus of this, is that the tennis ball here and the bottom of the slinky here do not move until the top of the slinky hits it. So we'll watch this a couple times. So you can see they really don't start falling until the slinky falls on top of them. So, like I said, the physics principles that you need to understand will be Newton's first law, which states that an object at rest will remain at rest, and an object in motion will remain in motion unless they're acted upon by an outside force. Essentially, if an object is doing something, whether that be doing nothing or moving, it will remain doing what it's doing until something pushes it. The next concept, it's not so important to really understand so much as just if you wanted to do the math with it. But it's important to know that the force applied by a spring is equal to the product of two values, one called K and one called X. K is called the spring constant, and X is called the displacement of the spring's end. Now, what do those actually mean? The spring constant, all that is a mathematical number between 0 and 1 that tells you how stiff or how soft a spring is, so how easy it is to compress. The displacement of the spring's end is just how far you stretch the spring. So here I have compiled a graph which will show you this green line, which is the position, the vertical position of the top of the slinky in meters above the ground, compared with the vertical position in meters of the bottom of the slinky and the tennis ball as time goes on. And as you'll notice, the tennis ball and the bottom of the slinky, they remain pretty constant. The only reason they're moving up and down is due to my error when actually trying to zoom in on the video and click each point that they were at during the time. So that's all human error. They really did stay pretty much at the same position. And if this graph went on a little bit longer, you would see that as the top of the slinky came into contact with these other two, that they would all move down towards 0 meters off the ground. So what does all this mean? And why is it important? I'm going to go with really why it's important. I feel like that's an easier thing to really understand. But the fact that while the slinky was dropped, the ball at the bottom didn't experience any force from that or didn't experience really anything until they hit each other. This can also be applied to sports such as golf, baseball, and softball, and really anything where a player is hitting the ball. And this is because, like, for example, when playing baseball, when the batter hits the baseball, the batter does feel something when he hits the baseball, but he doesn't feel it until the ball is already hit and moving in the other direction. And we don't really notice this because it happens within fractions of a second, but technically this is how it works. And again, all of this was mentioned in Veritasium's videos. I'm going to link 4 or 5 of his in the description that are very, very helpful when understanding this. And he does mention specifically these points. And he brings this other point up too, more in jest, but it's a fun thought exercise. That theoretically, if one were to jump out of a plane with with a very long slinky, if they're holding the end of the slinky, they can theoretically float in the air until the top of the slinky hits them. And that is all I have for today. Have a great day, and may God bless you.